Okay, let's start talking about solids. Solids of revolution. Solids of revolution. To talk about this today, the first graph we'll look at is f of x equals, let's say, e to the negative x. Okay? And first thing I want to do is sketch a graph. So a simple graph here of e to the negative x. Let's say here's 1, up there is 1, and we should all know that the graph of e to the negative x is going to, from 0 to 1 is going to do something like that. Okay? So a solid of revolution. What we want to do with this thing here, what we're talking about, the solid of revolution, is we're going to take this whole area here, this region underneath the curve, and we're going to wrap it around. In this case, we're going to wrap it around the x-axis. My x, there's my y. Okay? We're going to wrap it around. And to see how we do that, we have to see here, let's go in yellow, we take little slices of the region, and we look at them individually and wrap them around. And put it back behind. And these slices have a thickness, and the thickness of these slices is going to be, the thickness is going to be delta x. Okay? And so they have an area, and the area is going to be the radius of the area of the disk itself on the face there. It's going to be pi r squared. So the question is, what is r? So if I call right under the center, let's call that x naught. What's the radius of this thing going to be? It's going to be the length there. What is that distance? That is e to the negative x naught. Okay? And to see this a little clearer, let's pop this up. And here I have my graph, e to the negative x, and here is a little region. Right here would be my x naught, and we see the distance from there up to the graph is, of course, e to the negative x naught. And what we want to do is take that thing and wrap it around. And we see here that the width, that's my delta x, and then I want to look at the area of this face here, and it's going to be pi r squared, but my radius is going to always be from the x-axis to my line, which is e to the negative x naught, depending on where x naught is. So you see, if we do this for different values for x naught and add them all up, it looks like we might get the volume of this entire region. That is the volume of this three-dimensional region here. Okay? Let's undo that. So again, we're going to look at this. Let's figure out how to find the volume of that piece. So let's say the volume of a disk of one of our disks is going to be volume equals pi r squared times h. Alright? So in this case it's pi, and our r, let's look at one in particular here with the x naught there. Pi r squared is e to the negative x naught squared times h, and that's our thickness there, that's our delta x. So this equals pi e to the negative x, e to the negative 2 x naught delta x. And again, if we go back here, if we do that everywhere, we do that at every x coordinate I can. Go and get this thing to flip around. That's good enough. If I do this at every one of them, we see that, and we add it all up, we see we're going to have a Riemann sum. So that's going to tell us we're going to need to integrate from 0 to 1. And if we do it everywhere and add it up, we're going to get the volume of that region. Okay? So that is, if we do this at every x naught and add them up, we have a Riemann sum. That is, so the volume of the solid is going to be given by the integral from 0 to 1 of pi times e to the negative 2x naught. Oops, not x naught, just x, because now I'm doing it for all of them. There we go. Negative 2x dx. And remember, when we take the limit as this delta x goes to 0, we now notate it as dx. So this is going to equal a negative pi over 2 times e to the negative 2x from 0 to 1, which is going to equal, I'll do the positive one first, so when I put the 0 in, it's going to be minus the minus pi over 2. This is going to be positive pi over 2, then e to the 0 is 1, and then minus pi over 2 e to the negative 2, which equals pi over 2 times 1 minus pi over 2. Oops. I pour the pi over 2 out. So 1 minus e to the negative 2. And this is a volume, so whatever units you're measuring, cubic units. Okay? And that's going to conclude this video on solids of revolutions. Thank you.